Implementing conservation voltage reduction. So the discussion today, we're going to be looking at just an overview, the benefits, the challenges with it a little bit, and then the approach that we provide that you can take with the solution. And then feel free as we talk, questions, feedback. We benefit from not just hearing me, but from hearing some of you who may be doing something similar, who have experience with this stuff. We all benefit from it, so interject, because it makes my presentation better, and then I get rated better. So starting from a very high level, if my clicker works, simple depiction of an electric feeder. Where would your voltage be the highest for your distribution people? Yeah, closest to the substation. Unless Evan over there gets some massive solar or battery that's connected over here. But traditionally, what we see is your voltage starts the highest up here closest to the substation, and it gets lower over time. If you have some equipment in the middle, you're going to end up having a step up, because at the end of the day, what power are you required to provide to your customers? 114 to 124-ish, 126. So this is good. It's a trick question because it was on the slides for those who are observant. So 1 is here. You want to be within this good range. And so as we look at this, you want to make sure that everyone's within this, or else you're going to get a lot of flickering, a lot of complaints. And so oftentimes there's additional equipment that can be used on the distribution network to make sure you stay in those bounds. Now, in order to supply power at this level, generally it costs more to generate at this level here. And so the whole notion of conservation voltage reduction is how can you keep the end of the line within the bounds while at the same time lowering this as much as possible. That's in an effort to reduce the amount of power that you guys are purchasing. And so more or less that's conservation voltage reduction. It can go by a lot of different names. Volt-VAR optimization is going to be something similar with this notion as well, but it all has to do around voltage and lowering it down. So as we look at the benefits, what this basically is highlighting is the CVR factor. Has anyone heard of CVR factor before? Okay, there's a few nods. The definition used to refer to the ratio between voltage reduction and energy load consumption. Basically, what's the benefit that you're going to get? And so as you look at this, the bigger this is, the more benefit that you get by reduction in the voltage. And so as we look at, you've got a lot of different technology at place. And this is an oversimplification. So this is equivalent for those. So my experience with an electrical engineering degree, I spent a lot of money to have electrical engineering 101, where I've learned that voltage equals current times resistance. Spent a whole semester doing that, and then I go to the next semester and I learned that that's a lie. It's actually voltage equals current times impedance. And then I spend a whole semester on that to only learn that that's also a lie, and that they keep taking it. So there's a lot that you can get into this, but for 9 a.m. on a Wednesday, I don't want to put you guys to sleep. And so from a high level, this is the best place to start in understanding. While you look at your different feeders, the makeup of the feeder will influence how much benefit you're going to get from reduction. So incandescents, old AC units, refrigeration, things along these lines are a lot of benefit. But what's the challenge? How many of you still have incandescent light bulbs? Where most people, there's a big push obviously for LEDs, and the dilemma is LEDs are on this side of the axis and not this side of the axis, and so voltage reduction doesn't actually benefit heavy LED loads. And so with the advancement in technology, new TVs, personal computers, you actually have to account for the fact that some of these are going to have a slight negative impact when you're dropping voltage. And so we'll get into that a little bit more as well. So the challenge is why would I want to drop voltage when the thing that I sell is power? Some of you may be looking at that and say, wow, we run our stuff too low. Let's crank it up. Because we want to increase the load that is on our system. And so consumption's pretty flatlined over the last number of years. Part of that's in relation to the energy efficiency that we've seen going on, the LED light bulbs in place of the incandescents, things like that. And then a lot of it has to do with peak shaving and other reduction. But at the end of the day, what you're having to balance is, do I get more benefit in reducing my voltage and saving from those peak times as I do from power loss that I'm not going to be selling to my customer? And so this is very dependent on the nature of your feeder, the nature of your power purchase agreements. And so when you pursue something like this, I don't want to encourage you and say, all right, you're ready to go, you're going to save X amount of money immediately, because that may not necessarily be the case. Have many of you heard Don Bowman from Wake speak at all on CVR? So Don's a poster child for CVR. He saves a substantial amount of money with his solution. I don't see Don in here, so he would agree though. But the thing that is impacting it is the nature of his feeder. It's the nature of his power purchase agreements. And so it's just important that I don't want you guys to get this impression that it's going to be, you may be the new Don Bowman for us at the end of the day, but it's going to take a little bit of legwork to validate that. So this ties back to load profile has flattened a little bit, but the adoption of electric vehicles should give you all hope that there's going to be an uptick in consumption as people start charging their Leafs and their Teslas and all the supercharging infrastructure, and then battery capacity is expected to increase substantially as well. It depends on how you look at battery, because it may actually it may be a solution to CVR because it may offset your load and not necessarily be damaging to it, but that requires a lot of coordination on the utility as well. So EV is good, batteries may be good or bad depending on when they're charging and what type of, or what you can dictate at the end of the day of this utility. So when we look at the different components that make up CVR, there's 6 things that immediately come to mind. There may be some additional ones, but when we look at the solution from our perspective, we want to start with the meter. And so the piece that the meter plays is just acting as a sensor that's giving you a high fidelity, greater insight into your voltage profile. So instead of sending things every 15 minutes, you can get voltage sent to you every 5 minutes. And it's going to be a 1 minute average sent every 5 minutes. And that makes sure that as you're playing around your bounds, that you're not going to dip. The challenge is if you set it too high, you don't want to make the regulator, which we'll get into in a moment, bounce too much. So you want to have that, and we recognize 5 minutes satisfactory with that solution, but the meter is really providing you the voltage, which is critical to reducing your voltage. Voltage insight is the ability for you to see the said voltages from the meter and have it in a geographical representation. So it's just providing you an environment to review that. And then what we're going to get into in a few slides is the different ways these components can be put together to give you different options for a solution. So I'm just giving you a little bit of each one now, and then we'll highlight how they incorporate with one another. But we have the RTM. The RTM can be a piece of this component. We have Ryan Chattel, this is his baby. And if I open the opportunity for him, oh, excellent. He would probably spend the entirety of my session talking to you about the RTM. But for this purpose, the RTM gives you the remote connectivity to distribution assets in the field. So cap banks, voltage regulators, tap changers, circuit breakers, anything along those lines. This can tie to that distribution and provide switches. It gives you that remote access to control, operate, monitor, things along those lines. Keep going up. Distribution equipment. Sensus does not sell you transformers. We don't sell you breakers, reclosers, switches. But this is the piece of the equipment that's responsible for actually manipulating the voltage. All we're doing with this is measuring and sending out, visualizing, communicating. This is what does the legwork. This is the stuff that is a capital expense for you. And so when you look at your system and you look at feeders, the best place to start is, do I even have equipment that allows me to manipulate the voltage on my system? If you don't have that, you're going to have to do some investment on your distribution network to get up to speed to support a solution like this. So distribution equipment plays a large part. Is everyone familiar with SCADA in some capacity? So SCADA is the nice visual representation, not looking at necessarily meter data like Voltage Insight does, but it lets you see data from the distribution equipment. And so you have an environment to work with, control, and manipulate assets if you have connectivity. And then CVR algorithm. This is effectively any types of brains or automation that may go into controlling, identifying when to run the solution, what to run, things along those lines. Part of CVR meter, what we want to, was anyone in my IQ discussion before? Okay. So the challenge, and one of the things I spoke about it in IQ, trying to bring it all together, was we have this push towards multiple data sets. And so the shortcoming today, and it's maybe not necessarily a shortcoming, but if you want to do this, what ends up happening is to get 5-minute voltage data, because we only have one data set, everything within that data set that's valuable to you that you're communicating over the radio gets shipped up at 5 minutes. And so we're not going to make everything a CVR meter unless you want to buy a lot more network equipment. And Dave and other sales guys are more than happy to have that conversation with you. But realistically, and I think my next slide may actually go into it. And this point here is you don't need, for your purposes, and when we talk to Joe, it would be nice to know what you want to do with it. For CVR purposes, you don't need 5-minute data from every meter population as it relates to CVR. The focus is really on, you know your system very well to know where some of the outliers are as an initial pass, and then you know where you need to focus in. So this lets you leverage the network that makes sense so that you're not overhauling a network to get data that may not be necessary. So part of the IQ initiative about multiple data sets is to say, rather than sending everything at 5 minutes, we'll now give you the data set to say, here's your data for everything else you want to do at regular 15 minutes or whatever, and then you have one specific for like CVR that could be at the 5 minutes. And so that's kind of the approach, is helping you better leverage your network. So as we look at what the implementation looks like, this is 3 of many different factors and considerations that should go into your planning. So it's not on the screen, but the first one goes back to, do I have the distribution equipment to even manipulate the feeder to begin with? If you don't, it's going to take some money to get with that. But then it's important to look at who are my good candidates. So let's tie this back to that CVR factor. Do they have the CVR factor that's even going to benefit if I drop the voltage or not? And so some quick ways, there's a ton of IEEE material on this, around this, or there's numbers of consultants that play in this space as well. But basically, you can look at residential versus C&I, because there's a traditional load type that is equivalent to those, and research around which of those types actually benefit the most. Whether it's a short feeder or a long feeder plays an impact, and then summer versus winter as well. So there's others, but I just wanted to get the impression that as you dig into this, it will play an impact, because so if you try to implement it across the entirety of your solution that has maybe short versus long residential and C&I, you may not see a net benefit if some of these benefit and some of these don't. It may cancel. So you need to be strategic in your efforts, and I would recommend doing this simply so that you don't have to, if you have to make capital investment for distribution equipment, you don't want to just go and place it everywhere. You want to be strategic in your choice, and so it does take a little bit of analysis. One other thing, I know you're like, we're in a CVR talk, but why you bring up phase detection again and again? It's because we're excited about it, but there's also some anecdotal evidence we've heard where a consultant was speaking to, I think at Tech Advantage last year, and we hadn't thought of this yet, but basically they did an analysis like this, and the experience they had was, at first they got the results back and they go, well, that feeder is not qualified for CVR because your highs and your lows between your A phase and your C phase and the type of equipment, they didn't have single phase. It was all or nothing. And so for them, what they ended up doing was they ended up balancing out their circuit. They identified where some phases could be reoriented, some of the loads reoriented to different phases, and they actually balanced out their loads. So then, once they're balanced, they're actually benefiting from the CVR piece of it as well. So by having the proper phasing, you can then associate the load to the right phase, and you can figure out, hey, I can pull this load over to this phase, get some balance out because I know the load data, and then we're set up to run this. So food for thought with that. And then we'll dig into different implementations. So the first implementation would be looking just at, we look at putting the CVR meter in place. So placing a bellwether meter at the different locations, generally at the end of the feeder, at the end of the laterals, and then being able to use that, configure them to send up the data every 5 minutes. So we're pretty familiar with that. From there, what would end up happening is we send up that data to the base station, and then this gets routed into Census Analytics, and it's available inside of Voltage Insight. So this would be a solution if you don't have distribution automation in place, if you don't have remote communication to assets down the line. You're able to, if you want to, you can send someone into the substation to control this equipment, and you'll be able to look at Voltage Insight. You get the updates on the voltage as you're manipulating. So this is the quick and dirty way, so to say, if you have the distribution assets in place to be able to start benefiting from the meter's capability. So no, this was just an example of what Voltage Insight will end up showing you. I didn't want to get into a demo with all of this to be able to play around. I just wanted to capture some screenshots with it. There's more to it in here, but just to give you an impression of the reported voltage. And so you'd be able to look at that, look at your bellwether meters, and then being able to adjust accordingly. Yep, next slide. So this next one would end up requiring you to have a conversation with Ryan Chattel, which he's a great person to chat with, so go bug him afterwards. But this would be while we're more than happy, you would still benefit from that previous one. This simplifies the solution a little bit. You don't have to roll the truck. You don't have to get someone into the substation. It gives you the flexibility if you have the equipment and the sub on the feeder to sit at your operations center. You would get the data from the meters into Census Analytics, and then you'd be able to work within your SCADA system and manipulate your set points, do the control remotely, and so you're able to reduce your voltage in that fashion. And so this next one is similar to if you have the CVR meters in place, if you have the distribution equipment in place. This is for those individuals who don't want to have the manual intervention required with this. There's a number of, and we don't want to restrict you to saying we're not going to support sending the data over to third parties. We want to enable you to have that vendor choice where it makes sense. And so there's a number of vendors that are going to offer solutions in this space, but I will tell you that the vendors that do this, they've heard Don Bowman's story, they've heard other stories that Don's commented, and this is based off his power purchase agreement. It's $1 million+ that he can save. And so these guys are frothing at the mouth when they hear we have software that helps people save that amount of money. And so oftentimes you'll see that this can be a rather expensive solution to implement. A lot of people think software and they think a one-time buy and you're good to go, but a lot of times there's a lot of different ways that they're going to approach this topic. But it removes your involvement, and it really makes things a lot more efficient. So it's worth consideration depending on what makes sense for you. But if you have everything in place, it may squeeze out and pay for itself as well at the end of the day. So we just want to make sure that you know that through multi-speak, we're able to pipe that data into their software. They can tie into SCADA systems that tie back into automation control, which can control these assets. So there's a number of ways as you look at this that you can realize this type of solution. So we don't want to restrict it down to this is the only way to do it. There's a lot of flexibility in doing this and a lot of ways to work through and shaving your peak. When you look at customer benefits, the important thing about CVR, we've discussed this so far, has really been the utility benefits. How's the utility benefiting? And the utility does benefit quite a bit in this, but the anecdotal or the example I have is over the summer, a neighbor of ours babysits our daughter while my wife does some PRN work. And so the day before I'm supposed to drop her off, she asked us, can I watch the kids at your house tomorrow morning because my AC's not working? And we're like, sure, no problem. And the next morning we get a text message. It's like, oh, our AC kicked back on. She was going to have to call an electrician, get the AC guy to come check it out. So I started talking to her, and she goes, it turns out I actually participate in a load control program. And they were running the load control program from 5 p.m. to like 8 p.m. that night. And so she forgot that she participated in the load control program. And so she's frantically trying to figure out, how do I get an AC person to come fix my stuff because my AC is not working? And that was all for the benefit of her getting a little bit of kickback in the program participation, but mostly for the utility to be able to shave their peak. And so what CVR affords you as a utility is you offer similar benefits without the pain that customers may often experience by forgetting that they're in the program, by having their AC turned off. What actually happens is when you reduce the voltage, there was some concern at a time, but a lot of equipment may run better at lower voltages, and in turn, they actually consume less. And so the customer's bill may actually be reduced by a little bit depending on how you run this. And I was bring Don back into this at breakfast this morning, I asked him that question of, were you not concerned that you're going to end up losing revenue by running this so often? You're going to not sell as much power, and so how do you make that decision? And his feedback to me was, I lose $3,000 in electric sales by running it at this peak time. He's like, but I save $90,000. He's like, every day, that math works in my favor. And so as you look at it, is it going to be 24 hours a day, 7 days a week? No, but when you run it strategically, you can even run it throughout the year, depending on how your agreement and services are set up. And so the homeowner, they may get a little bit lower bill, but if you're set up with a peak like they are, you're going to end up benefiting in the long run. And so the customer they don't notice it. And I'm not trying to talk you out of demand response, because there's a place for it. But CVR is the stuff that works in the background that has a little less pain, and it's not nearly as identifiable as demand response is. So it's definitely worth consideration. So I think I'm a little bit early, but I think the next slide's questions. So any questions?